Neptune, the eighth planet from our Sun, reigns as a majestic blue giant in the cold depths of our solar system. Circling this distant giant is a retinue of 14 known moons, each a world unto itself, each holding secrets yet to be unlocked. Among these frozen sentinels, one stands out, a moon as enigmatic as it is intriguing, Nereid. Its orbit is a chaotic masterpiece, a wild and eccentric path that sets it apart from the more conventional moons of our solar system. The discovery of Neptune's moons, including Nereid, opened a new chapter in our understanding of the outer solar system. They challenged our assumptions about the nature of planetary systems and pushed the boundaries of our scientific knowledge. Neptune's realm is a far cry from the familiar warmth of our Sun. In this frigid environment, water exists only as ice, and the very air we breathe would freeze solid. Yet despite these harsh conditions, a surprising diversity of worlds exists. Among these icy denizens, Nereid stands out. Scientists believe it to be primarily composed of ice, mixed with darker, more primitive materials. This composition hints at a formation in the early solar system, a time when the planets were still coalescing from a swirling disk of gas and dust. Nereid's unique orbit is a puzzle that has intrigued astronomers for decades. Unlike most moons, which follow relatively circular paths around their planets, Nereid's orbit is highly elliptical. This unusual orbit suggests that Nereid may not have formed in its current location. One intriguing possibility is that Nereid is a captured object, a wanderer from the outer solar system that was ensnared by Neptune's gravity. By unraveling the mysteries of Nereid, we can gain a deeper understanding of the processes that shaped our cosmic neighborhood and the incredible diversity of worlds that exist beyond our own. The year was 1949. Astronomers, armed with increasingly powerful telescopes, were turning their gaze towards the heavens, eager to unlock the secrets of the cosmos. It was in this era of discovery that Nereid, the enigmatic moon of Neptune, would first reveal itself to human eyes. The discovery of Nereid was not a moment of sudden revelation, but rather the culmination of careful observation and a touch of serendipity. The credit for this discovery goes to Gerard Kuiper, a Dutch-American astronomer who would later become a towering figure in the field of planetary science. Kuiper was already renowned for his work on asteroids and the outer solar system, but his discovery of Nereid would cement his place in astronomical history. Gerard Kuiper's quest to find a moon around Neptune was not driven by mere chance. He suspected that the giant planet might harbor an undiscovered satellite, based on his analysis of Neptune's gravitational influence on its surroundings. Armed with this hypothesis, he embarked on a systematic search, using the powerful 82-inch Otto Struve telescope at McDonald Observatory in Texas. On May 1, 1949, Kuiper's persistence paid off. The discovery of Nereid was met with excitement by the astronomical community. It was the first new moon to be discovered around Neptune in over 80 years, and its unusual orbit immediately set it apart from its counterparts. In the years following its discovery, Nereid remained a tantalizing enigma, its secrets hidden by vast distances and the limitations of Earth-based telescopes. Astronomers could glean only the most basic information about Nereid from their observations, such as its orbital characteristics and its approximate size. One of the most striking features of Nereid's orbit, even from these early observations, was its extreme eccentricity. This meant that Nereid's distance from Neptune varied dramatically throughout its orbit. This unusual orbital behavior hinted at a turbulent past, possibly involving gravitational interactions with other celestial bodies, or even a capture event billions of years ago. But without more detailed observations, the true nature of Nereid's origin story remained elusive. Despite the challenges of observing such a distant and faint object from Earth, astronomers were able to make some intriguing discoveries about Nereid. By carefully analyzing the light reflected from its surface, they were able to determine that Nereid was a relatively small object, with an estimated diameter of about 340 kilometers or 211 miles. These early observations also revealed that Nereid's surface was quite dark, reflecting only a small percentage of the sunlight that reached it. This suggested that the moon's surface was likely composed of a mixture of ices, such as water ice and frozen methane, along with darker, more primitive materials, perhaps remnants from the early solar system. These early findings, though limited, only deepened the mystery surrounding Nereid. The answers to these questions would have to wait for the arrival of a new era of space exploration, an era that would allow us to visit these distant worlds and unlock their secrets firsthand. Nereid's orbit is a celestial ballet unlike any other in our solar system. Unlike the more sedate, nearly circular orbits of most moons around their planets, Nereid's path around Neptune is a highly elongated ellipse. This extreme eccentricity is a telltale sign that Nereid may not have formed in its current location. It suggests a history of gravitational interactions, perhaps a close encounter with another celestial body or even a capture event billions of years ago. During this turbulent era, it's possible that Nereid, perhaps originating in the distant Kuiper belt, was drawn inward by Neptune's gravitational pull. This capture event, if it occurred, would have left an indelible mark on Nereid's orbit, flinging it into the eccentric path we observe today. Nereid takes a leisurely 360 Earth days to complete one orbit around Neptune. Throughout this year-long odyssey, Nereid's distance from Neptune varies dramatically, from a relatively close approach of about 1.4 million kilometers to a staggering 9.7 million kilometers at its farthest point. This means that Nereid experiences extreme variations in temperature and solar radiation throughout its orbit. At its closest approach, Neptune's pale sunlight would bathe Nereid in a faint, ethereal glow, but as it swings out towards its farthest point, the distant sun would dwindle to a mere pinprick of light, and Nereid would be plunged into a frigid darkness. These extreme variations in temperature and illumination likely have profound effects on Nereid's surface and its potential for harboring any traces of volatile substances, such as water ice. Understanding these orbital dynamics is crucial for unraveling the history of Nereid and its potential for revealing clues about the early solar system. Though we have yet to send a spacecraft to Nereid for a close-up look, astronomers have been able to piece together some tantalizing clues about its surface from Earth-based observations. These observations, while limited by distance and the faintness of Nereid's reflected light, reveal a world shaped by time, ice, and the relentless bombardment of micrometeoroids. Nereid's surface appears quite dark, reflecting only a small percentage of the sunlight that reaches it. This suggests a composition dominated by dark reddish materials, perhaps rich in organic compounds or minerals altered by exposure to radiation over billions of years. This dark surface is also pockmarked by craters of various sizes, evidence of a long history of impacts from asteroids and comets. Studying the distribution and characteristics of these craters can provide insights into the impact history of the outer solar system and the types of objects that have populated this region over billions of years. Despite decades of observations, Nereid's composition remains a subject of ongoing scientific investigation. While we know that its surface is dark and likely rich in organic compounds, the exact proportions of different ices and minerals remain uncertain. Some scientists speculate that Nereid's reddish hue may indicate the presence of tholins, complex organic molecules formed by the interaction of solar radiation with simple organic compounds. These tholins are found on other bodies in the outer solar system, such as Pluto and Triton, Neptune's largest moon, and their presence on Nereid could provide further evidence of a shared origin or similar evolutionary processes. Determining the exact composition of Nereid is crucial for understanding its formation and evolution. Further observations, perhaps using telescopes equipped with spectrographs that can analyze the light reflected from Nereid's surface in more detail, are needed to unlock these secrets. Nereid, with its ancient surface and chaotic orbit, stands as a cosmic time capsule, holding clues to the tumultuous early days of our solar system. By studying Nereid, we can peer back through time, unraveling the story of our solar system's formation and the processes that shape the planetary landscape we observe today. Imagine, if you will, the young solar system, a swirling disk of gas and dust surrounding our newborn sun. Planetary embryos, massive clumps of material, jostled for position within this cosmic maelstrom, their gravitational fields drawing in surrounding debris, growing larger and more influential with each passing eon. It was during this epoch of planetary upheaval that Nereid likely took shape, its composition reflecting the materials available in the outer reaches of the nascent solar system. By comparing these isotopic signatures to those found in other bodies throughout the solar system, scientists can piece together a more comprehensive picture of the early solar system's structure and evolution. Section 2. Gravitational Choreography. Deciphering the Dance of Distant Worlds. Nereid's eccentric orbit is a key to understanding gravitational interactions in the outer solar system. Its chaotic dance around Neptune reveals the gravitational ballet involving moons, comets, and giant planets. Tracking Nereid's orbit helps astronomers deduce gravitational influences over time. Subtle variations in its orbit may reveal unseen moons or even hints of a hypothetical Planet 9. Nereid's orbit provides insights into the outer solar system's history. Its eccentricity indicates the frequency and intensity of past gravitational encounters. A highly eccentric orbit suggests significant gravitational perturbations, possibly from the late heavy bombardment. Section 3. Captured in Neptune's Embrace. The implications for planetary migration. Nereid, a captured object by Neptune's gravity, offers insights into planetary migration in the early solar system. If Nereid originated in the Kuiper belt, its capture supports large-scale planetary movements. The NICE model suggests giant planets formed closer to the Sun and migrated outward. Gravitational interactions caused planets to migrate, scattering bodies like Nereid. Nereid's capture by Neptune supports the NICE model, showing planetary migration's impact. Studying Nereid's capture helps refine models of planetary migration and solar system formation. Section 4. A Beacon from the Edge. Nereid's role in understanding distant planetary systems. Nereid, though a small and seemingly insignificant moon in the vast expanse of our solar system, holds lessons that extend far beyond our immediate cosmic neighborhood. As we discover more and more exoplanetary systems, planetary systems orbiting stars other than our Sun, we are finding that many of them harbor their own populations of irregular satellites, moons with eccentric orbits and intriguing histories. Nereid, with its well-studied orbit and intriguing surface properties, can serve as a valuable analog for understanding these distant, often fainter, exomoons. By studying Nereid's composition, surface features, and orbital dynamics, we can develop models and refine our observational techniques, improving our ability to characterize and understand exomoons around other stars. These exomoons, like Nereid, may hold clues to the formation and evolution of their own planetary systems, providing insights into the diversity of planetary architectures and the processes that govern planet-moon interactions throughout the cosmos. Nereid, once a solitary enigma in the outer reaches of our solar system, now stands as a beacon, guiding our exploration of planetary systems far beyond our own. The Scattered Disk, A Nursery for Icy Wanderers. Journey back to the dawn of our solar system, when giant planets carved paths through the protoplanetary disk. Beyond the gas giants lay the scattered disk, a chaotic region of icy planetesimals, the building blocks of planets. These icy bodies, ranging from pebbles to dwarf planets, were scattered by migrating gas giants. Imagine a cosmic game of billiards, with giant planets as cues, sending icy objects in all directions. Some were flung out of the solar system, while others settled into distant orbits, forming the Kuiper belt and Oort cloud. Nereid's eccentric orbit suggests a chaotic origin. Its path hints at gravitational interactions, perhaps with giant planets or passing planetesimals. These interactions perturbed its orbit over millions of years. As the giant planets migrated through the early solar system, their gravitational fields sculpted the orbits of smaller bodies like Nereid, capturing some and ejecting others. Neptune, with its powerful gravitational pull, would have been a major player in this cosmic dance, drawing in objects from the scattered disk and shaping their destinies. One scenario for Nereid's capture involves a close encounter with Neptune during the giant planet's outward migration. Imagine Nereid, minding its own business in the scattered disk when Neptune on its outward journey swept through its neighborhood. Neptune's gravity would have tugged at Nereid, pulling it off its original trajectory and into a chaotic dance around the giant planet. This gravitational tug-of-war would have left an indelible mark on Nereid's orbit, stretching it out into the highly elongated ellipse we observe today. The exact details of this capture event, such as the angle of approach and the relative velocities of the two bodies, would have determined the final shape of Nereid's orbit and its fate as a captured moon of Neptune. The strongest evidence for Nereid's capture comes from its orbital characteristics, which set it apart from Neptune's other regular moons. Unlike the inner moons, which orbit Neptune in a relatively flat plane and in the same direction as the planet's rotation, Nereid's orbit is highly inclined, tilted at a steep angle to Neptune's equatorial plane. This orbital tilt is difficult to explain if Nereid formed in situ, coalescing from a disk of material around Neptune like its inner siblings. Such a disk would have naturally flattened out under the influence of gravity, producing moons with orbits aligned with the planet's equator. Nereid's high inclination, on the other hand, is consistent with a capture origin, as an object captured from the scattered disk would not be bound to the same orbital plane as Neptune's regular moons. The chaotic nature of the scattered disk, with objects moving in all directions, could easily account for Nereid's tilted orbit. Section 4. A window into the Kuiper belt. Unveiling Nereid's primordial origins. Nereid, a potential Kuiper belt escapee, offers insights into the early solar system. Its icy composition reveals conditions from billions of years ago. Studying Nereid could revolutionize our understanding of the outer solar system's formation and evolution. Section 1. Nereid, a sentinel of the outer solar system. In the cosmic expanse, Nereid circles Neptune, a silent sentinel guarding secrets of the outer solar system. Its journey, a testament to the chaotic dance of gravity, paints a unique narrative across the cosmos. Nereid is a time capsule, its icy surface bearing witness to the tumultuous birth of our solar system. Its eccentric orbit hints at a past marked by gravitational encounters. Nereid's significance to our understanding of the outer solar system is undeniable. By studying Nereid, we gain a deeper appreciation for the intricate workings of gravity. Section 2. Uncharted Territory. Future exploration of an enigmatic moon. Despite decades of observations from Earth-based telescopes and fleeting glimpses from passing spacecraft, much about Nereid remains shrouded in mystery. Its surface composition, the details of its internal structure, and the possibility of harboring any traces of volatile substances, such as water ice, remain open questions, tantalizing targets for future exploration. Imagine a future mission dedicated to unlocking Nereid's secrets. A spacecraft, equipped with state-of-the-art instruments, could make a daring rendezvous with this distant moon, piercing the veil of distance and revealing its true nature in unprecedented detail. High-resolution cameras could map its cratered surface, revealing the scars of its long journey through the solar system, and providing clues about the impact history of the outer solar system. Spectrometers, capable of analyzing the light reflected from Nereid's surface, could determine the composition of its icy crust, identifying the presence of specific minerals and organic compounds that could shed light on its formation and evolution. Radar instruments could peer beneath the surface, mapping its internal structure and revealing any hidden layers of ice or rock that might hint at past geological activity. Section 3. Expanding our cosmic horizons, Nereid's place in the grand tapestry of exploration. Nereid's story is a testament to the human spirit of exploration and our curiosity to understand the cosmos. As we venture further, Nereid reminds us of the vastness yet to be explored. The lessons from Nereid extend beyond our immediate cosmic neighborhood. By studying Nereid, we gain insights into exomoons and planetary systems. Nereid, once a faint point of light, symbolizes boundless discovery opportunities. Its story is a testament to human ingenuity and collaboration. Nereid will continue to inspire us, reminding us that the greatest discoveries often lie hidden in unexpected places.